Hi YouTube friends, I'm teacher Regy Safadão, and today we are going to talk about the trigonometric ratios and the right triangle. Are you ready? So, join us! Hi YouTube friends, I'm teacher Regy Safadão, and today we are going to have our class number 2 of 5. See our opening. As you already know, this is our channel of mathematics with different years, and here you have classes of physics, mathematics, and English in 2 versions. One version in Portuguese and the other version in English, okay? And today we are going to talk about trigonometry in the right triangles, okay? Talking about trigonometric ratios. All right, here we have an yellow triangle, okay, A, B, and C. This triangle is right in A, okay? So it means that this angle here is right, so it is 90 degrees, okay? Well, this is, let me get a laser pointer here in order to show you to point things better. Okay, so this angle right here is angle X. Okay, so things are going to happen according to this angle, all right? Well, you already know that this largest side is hypotenuse and the other sides are the legs. Okay, now the legs are going to receive different names. Okay, pay attention. This is the hypotenuse because this is the largest side, and this is right in front of, okay, the right angle. And the other sides are now the adjacent side to X, and the other is the opposite side to X, okay? See, adjacent because it is near to the X angle, and the opposite because it's on the other side of the angle, okay, of the X angle. Now, let's see one point. Soa, ka, toa. I'm going to explain it later, okay? Let's see now, according to the definitions, sine, cosine, and tangent of x, okay? So sine of x is always the opposite side to x divided by the hypotenuse. Cosine of x is always the adjacent side to x divided by the hypotenuse, and tangent of x is always the opposite side to x divided by the adjacent side to x. Okay, so according to their definitions, sine is always like this. Sine is opposite side divided by the hypotenuse. Cosine is always adjacent side divided by the hypotenuse. And tangent is always the opposite side divided by the adjacent side. So this is why we have here soa, ka, toa. Okay, it is something created to make you remember the definitions of sine, cosine, and tangent. All right, very good. So let's go on. Now, let's see the right triangles. Oh, the standard angles, okay? So listen to this. The following angles are very much used in trigonometry. They are known as standard angles: 0 degree, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Their values are in the table below. Okay, so see, this table needs to be memorized, okay? Because the word problems usually don't give their values, so we need to know them by mind, okay, by heart, I mean, okay. Well, so let's see. The sine of 0 degree is 0. The sine of 30 degrees is 1/2. The sine of 45 degrees is root of 2/2. The sine of 60 degrees is root of 3/2, and the sine of 90 degrees is 1. Cosine. Cosine of 0 degree is 1. Cosine of 30 degrees is root of 3/2. Cosine of 45 degrees is root of 2 over 2. Cosine of 60 degrees is 1 over 2. And cosine of 90 degrees is 0. All right? And now tangent. Tangent of 0 degree is 0. Tangent of 30 degrees is root of 3 over 3. Tangent of 45 degrees is 1. Tangent of 60 degree is root of 3. And finally, tangent of 90 degree is undefined. All right? Now, we have 6 word problems in order to be solved, okay? And practice more and more, all right? Let's get used. Let's see question 1. Now, let's do some exercise, okay? See, question number 1, okay? We have some word problems here. Determine the length of the diagonal D of the parallelepiped shown in the following figure. So we have a figure of a parallelepiped here. And this side of the parallelepiped is 60 centimeters and the diagonal is D. Okay, pay attention. Okay, so the diagonal is D. Well, pay attention. Here is the right angle. So D is the hypotenuse. All right. This side here is very near to the angle of 30 degrees. So this is the opposite side. No, this is the adjacent side because adjacent is a synonym to the word near. All right. So it's very easy, you see. The opposite side should be this one, okay? But it's not going to be used in this problem, okay? So because we want to find the diagonal, all right? And 60, okay, centimeters is the, yes, adjacent side. So what involves adjacent side and hypotenuse? Sine, cosine, or tangent? Good, cosine. So we have the question here involves a cosine. So cosine of 30 degrees is the adjacent side divided by the hypotenuse. So now let's replace the values like this. Cosine of 30 degrees, you remember I told you to memorize that table. Okay, so the cosine of 30 degree is root of 3 over 2. Okay, I am replacing the values. The adjacent side is 60 and the hypotenuse is the diagonal. All right, now let's multiply like this, crossing, okay, this way. So we are going to multiply this way and this way, you know, crossing like this. I'm going to show you. You see, let's multiply like this and like this. Okay, so we have okay, don't forget, the root of 3 is about 1.73. Now, let's see. We have root of 3 times D, the diagonal, is 2 times 60 because I multiplied in this way. Okay, this and this. Okay, crossing the values. All right. Well, let's replace the value of the square root of 3. Okay, so it is 1.73 times D is 120. Why 120? Because it is 2 times 60. Okay, now 1.73 is multiplying. It comes to the right side of the equation, dividing. Okay, so let's go. So the diagonal is 120 divided by 1.73. Doing the division, we have the diagonal is 11.56 centimeters. Okay, so question number 1 is done. Let's go to question number 2. It's another word problem. Okay, so an aircraft takes off at an angle of 60 degrees. What's the space traveled by it from takeoff until reaching the altitude of 2,500 meters? Let's see a figure. Okay, oh, this arrow right here, okay, is supposed to be the aircraft, okay? So the figure is only to make you understand the situation. Okay, so pay attention. This is the aircraft, and this is the distance the aircraft traveled. Okay, we want to know about this. We want to know the value of x. Okay, this trajectory here. Well, the angle is 60 degrees. The altitude of the aircraft is 2,500 meters. Okay, well, if this is the right angle, what it means? It means that x is the hypotenuse. Okay, so what involves hypotenuse and the opposite, because this is the opposite side, isn't it? This is the opposite side to 60 degrees, isn't it? Yes, it is. So question number 2 is a sine. Very good, because sine involves opposite side and hypotenuse. All right. Well, as I told you to memorize, remember, what's the sine of 60 degrees? Yes, it is the square root of 3 over 2. Okay. So it is here. I replaced it already. The opposite side is 2,500. And the hypotenuse is x. So let's multiply crossing the values, okay? So let's multiply like this. The square root of 3 times x and 2 times 2,500, okay? Like this, I'll show you. This way. Oh, square root of 3 is about 1.73. It's something that you need to memorize as well, okay? So you can multiply crossing. Okay, so let's start. The square root of 3 times x, you see, and 2 times 2,500. Okay, well, let's replace the square root of 3. It's 1.73, and let's multiply 2 times 2,500. So I have here 1.73 times x is 5,000. Okay, now 1.73 is multiplying. It's going to come to the right side of the equation, dividing because of the reverse operations, remember? So x is 5,000 divided by 1.73, and dividing it, we have that x is 2,890.17 meters. Okay, so this is the answer of word problem question 2. Let's see question 3. A boy is flying a kite at noon using a thread of 108 meters long. Knowing that the angle formed by the thread and the ground is 45 degrees, also supposing the thread is perfectly stretched, find the distance between the boy and the kite shadow. Let's see. The figure is just to make you understand the situation. Okay? So it is something like this. Okay? The sun is up there. Okay, remember it is noon. So the sun is up there. Okay, this is the boy. He's flying a kite. All right. And well, of course, if the sun is right up there, the shadow, okay, the kite shadow is going to be right here in the same direction. All right. So this is the situation. There are some more things to be understood. Okay. To be understood. So 108 meters, okay, is the thread. The angle is 45 degrees, okay. It says here the angle formed by the thread and the ground is 45 degrees. Very good. So they want to know the distance between the boy and the kite shadow, like this, okay. So pay attention. If this is the right angle, 180 meters is the hypotenuse. Very good. And 45 is the degree here, okay, of this triangle. And x is here, okay. So x is a leg. But is it the opposite side or the adjacent side to 45 degrees? Yes, it is the adjacent side to 45 degrees. Okay, so it is a sine, a cosine, or a tangent. What involves adjacent side and hypotenuse? Cosine, very good. So we have cosine of 45 degrees. It is adjacent side divided by the hypotenuse. Okay, so now let's replace the values. Cosine of 45 degrees is square root of 2 over 2. Yes. Adjacent side is x and the hypotenuse is 180. Okay. Now let's multiply in cross. Okay. As I told you. Okay. The square root of 2 is about 1.41. Okay. So let's multiply this way. Okay. So 2 times x is 180 times the square root of 2. Okay, now let's replace this, okay, and divide the equation by 2, okay? Something like this, okay? So I replace it, the square root of 2 is 1.41. Now multiply like this. So doing the multiplication, we have 253.8 over 2. And doing the division, x is 126.9 meters. All right. So it was question 3. Let's see now question 4. So word problem number 4. Determine how tall the building below is, knowing that when the sun is 60 degrees above the horizon, the projected shadow of the building is 80 meters long. Let's see the situation. Okay. The figure is to make you understand the situation. This is the building. The sun is up there. All right. So the shadow of the building, okay, is here on the ground, okay, because the sun is here. So this is the shadow of the building. And the problem says that the shadow is 80 meters long. Okay, so 8 meters is the shadow. Okay, let's see. Okay, the angle is 60 degrees, and we want to know how tall the building is. Okay, well, don't forget, we have to find if it is a sine, a cosine, or a tangent. All right, well, we want to know how tall the building is. Okay, so we want to know this. Okay, this is the opposite, or this is the adjacent side. What do you think? Okay, the angle is here. It is the opposite. Okay, the opposite side. And 80 meters is the adjacent side. All right. So what involves opposite and adjacent sides? Good, tangent. So our word problem here is a tangent of 60 degrees. So the opposite side divided by the adjacent side. Let's replace values. Tangent of a 60 degree is the root of 3. I wrote here number 1, okay, because I want to show you how we can do it as fast as possible. Okay, so you can multiply this way. Oh, the square root of 3 is 1.73. So multiply this way. You see? Very good. So 1 times h is h, and 80 or 80 times the root of 3, we can do like this. Okay, well, let's replace the value of the square root of 3. So it means that h is 80 times 1.73. Well, doing the multiplication, so the building is 138.4 meters. Okay, very good. It was question number 3. Let's see question number 5. Word problem 5. A ladder is supported on top of a wall, forming with the ground an angle of 30 degrees. Knowing that this wall is 6 meters high, as shown below, determine in meters how long this ladder is. Let's do it. Okay, this is the wall. Yeah. Okay, it is about 6 meters. Okay. Oh, this is the ladder. Okay. Very good. Excellent. Okay, 30 degrees. X. And here, don't forget, this is the right angle. Okay, this is the right angle. So it means that X, the ladder itself, okay, is the hypotenuse. All right. And 30 degrees is here. So it means that 6 meters is what? Opposite side or adjacent side? Yes, the opposite side. Okay, so is it a sine, a cosine, or a tangent problem? Very good. It is a sine because only sine involves opposite side and hypotenuse. Okay, so now let's replace the values. What's the sine of 30 degrees? You remember? Yes, it is 1/2. Okay, very good. And the opposite side is 6. Hypotenuse is x. So easily we do it. Okay, so we can do multiplying this way. Okay, crossing the values. 1 times x and 2 times 6, like this. Okay, well, 1 times x is x. 2 times 6 is 12. So x is 12 meters. Okay, let's do question number 6, our last word problem. Question 6. Calculate the height, measure x, of the tower of the Notre Dame Cathedral constructed in Paris, knowing that a tourist is at a distance of 52.02 meters far from this cathedral and sees its highest point under an angle of 60 degrees. Okay, so let's draw the cathedral. Okay, supposing this is the cathedral. Remember, the figure is just to make you understand the situation, all right? So this is the tourist, okay? And the problem says that he is 52.02 meters away from the cathedral, all right? So we want to know how high it is. So, yeah. Okay, 60 degrees. This is the right angle, remember? So if this is the right angle, this is the hypotenuse. And this problem does not involve hypotenuse, only opposite side and adjacent side. So it is a tangent. Very good, because tangent is the only one that does not involve hypotenuse. Okay, so let's do tangent of 60 degrees is the opposite side over the adjacent side. Okay, so let's replace the values. Okay, so the tangent of 60 degrees is square root of 3. Okay, opposite side is x, and the adjacent side is 52.02. Okay, the square root of 3 is about 1.73. Good. Now let's multiply crossing. Always like this. Okay, so 1 times x and 52.02 times the square root of 3, like this. Okay, so easily we can do 1 times x is x. 52.02 times, don't forget to replace this value right here. Okay, like this. Okay, now it's better. 1.73. Now let's multiply. So it gives us that x is 90 meters. Okay, so this is the measure of the tower of that cathedral. All right, well, this is our last question. Okay, our last word problem. So we've come to the end of another exercise. Well, thank you very much for watching our class until the end, our video until the end. All right, I am teacher Regy Safadão, wishing you an excellent week. All right, thank you very much. See you. Bye-bye.
That's all, folks.